Hello guys, please I just want to clear your doubt on some things. So please make sure you get to the end, especially the end, because that is where most of the things that I want to clarify are. I just want to actually go over these questions again. Now, this question here says, in the compound, this is the compound that was given to you. The NH2 will be activating the following position for the electrophilic substitution. Now, we said activating agents, activating groups usually direct to which of the position, the octo and para. Okay, the activating group usually direct to octo and para, and NH2 is activating, so it will direct to the octo and the para position, and that makes option A the correct answer. Octo and para position, that is the correct answer to that question. Now the next one says, in the following compound NO2, you have the compound, the NO2 group will be activating the following. It will be deactivating, this is not activating, be deactivating the following position for electrophilic substitution. Now the correct answer is NO2 would be deactivating, or let's NO2 is deactivating. Okay, the position that it will direct to, it will direct the nucleophile to, or the electrophile to, is the meta position, because we said deactivating agent usually direct to the meta position, Please, I will be a little bit fast. Now, in this compound given to you, which is the meta position and which is the octo? Now we said the position directly close to it is octo, then this position is usually meta, and then the position directly opposite it is what? Is the para position. So this will direct to the meta position, and that makes option B the correct answer to this question. Let's look at the next. Elimination reaction is favored over substitution reaction under the following condition, except elimination is favored over substitution reaction under the following condition, except. Now I think the correct answer is C, weak and dilute bases. That should be the correct answer, not non-polar solvent. Okay, weak and dilute bases usually favors elimination reaction. Okay, yes, strong bases favors elimination reaction as compared to substitution reaction. Okay, also non-polar solvents also favors elimination substitution reaction than elimination. So let's go with option D, which is the correct answer here. Non-polar solvent favors substitution reaction than elimination. Let's go with this one, non-polar solvent, because weak and dilute bases also we have SN1 reaction. SN1 is also substitution. I was looking at it from the angle of SN1 and SN2. SN1 is also substitution reaction, and hence weak basis favors, or weak and dilute basis favors SN1. Are we getting it? But when we are talking about elimination and substitution, the correct answer is non-polar solvent. Elimination reaction is favored over substitution reaction under the following condition, except non-polar solvent. Substitution reaction is favored over elimination reaction under a condition of non-polar solvent. But when they say except here, it means the correct answer is non-polar solvent. Okay, now the next question is, E1 is favored over E2 pathway under the following conditions, except. E1 is favored over E2 pathway under the following condition, except. The correct answer is solvents with high polarity. E1 is favored over E2 pathway under the following condition, except solvents with high polarity. Okay, that's the correct answer. Now the next one says, SN1 pathway is favored over SN1 under the following condition, except. SN1 pathway is favored over SN2 under the following condition, except. Use of non-polar solvent. Yes, use of non-polar solvent favors SN2 than SN1. So when they say SN1 pathway is favored over SN2 pathway under the following conditions, except, the correct answer is what? Use of non-polar solvent. Okay, use of non-polar solvent. Now the next one is, I think is the same question here. Now the next question says, use the structure below to answer the following question. This is where I want your attention to focus your attention on. This is where I will be spending a lot of time. Use the structure below to answer the following question. What is the hybridization of the carbon atom labeled A in this compound? Now this hybridization here is sp2. The hybridization of the carbon atom labeled A is sp2. How many sigma bonds are present in this compound? Now whenever they tell you, they ask you the number of sigma bond, what you do is to bring out the molecule in its O form. Now this molecule, you can draw it like this. Okay, if you bring it out in its O form, this double bond, this double bond, now there will be a bond here to complete the valency of carbon to be 4. This one is already complete 4. There is a bond here to complete the valency, a bond here. Then we have 2 bonds, and then 2 bonds to complete the valency. Then we have carbon here. This one, the valency is complete, carbon. Then this one also, you have these hydrogens here. There are how many hydrogens here? There are 3 hydrogens. You must spread them out. So I think the valency of everything is complete here. So how many sigma bonds are present? This. Now the question says, how many sigma bonds are here? Now for us to count the sigma bond, I told you that you must bring out the valency to complete 4 for carbon and the rest. Okay, now in this case we said that every single bond is a sigma bond. A double bond contains 1 sigma bond, and a triple bond also contains 1 sigma bond. So how many sigma bonds are here? All single bond will be regarded as sigma bond. All double bond, one of the double bond will be regarded as what? Sigma. So you have 1, 2, there is another here, 3, and then 4, 5, 6. Then here is 7, 8, 9, 10. Then we have 11, and then here is 12. Here is 13, 14, 15, 16, 17, and finally what? 18. So in this compound there are 18 sigma bonds. Okay, there are 18. You must bring them out. Whenever they give you any compound, whether in the cyclic form or you must bring it out in the structural form in such a way that you now count all the single bonds and the double bond. One of the bond is a sigma. When you have a triple bond, 1 is a sigma. So you count all of them to ascertain the total number of sigma bond. What is the hybridization of the carbon labeled C? Now this is the carbon labeled C. The hybridization here is sp3 because they are all single bonds around this carbon. If you bring it out, this is hydrogen, 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 and then you have another bond here. So around this carbon, all the bonds here are what? Sigma bond. I would say when we have 4 sigma bond, the hybridization is what? sp3. So that is the correct answer to that question. Now the next one says, what is the hybridization of the carbon labeled B? Now this is the carbon labeled B here. What is the hybridization of this carbon? This carbon has, if you want to bring it out, it has a single bond, then triple bond. Now in this triple bond, there is 2 pi and 1 sigma. So there are 2 pi and 1 sigma, and then another sigma. So in total we have 2 pi and 2 sigma. We say whenever we have 2 pi and 2 sigma, the hybridization is what? sp. So the hybridization of the carbon labeled B is what? Is sp. Now the most important question here is, how many pi bonds are present? How many pi bonds? Now listen and listen carefully. Whenever you are given anything like this, the pi bond is telling you the number of double bond or triple bond present in the particular question. That is where you should go to whenever you hear of pi bond, okay? And you don't count the carbon. They didn't ask you the pi carbons. Say pi bond. A bond is usually a linkage between two carbons, so you don't count the two carbons separately, you only count the bond. So in this case, there is a pi bond here, there is another pi bond here, and here we said that wherever we have a triple bond, one of the bond is a pi bond and the other two of the bonds are pi bonds and the other is a sigma bond. So here we have 2 pi bond and 1 sigma. So in total, how many pi bond do we have here? We have 4 pi bonds in this particular compound. So we have 4 pi bonds and 18 sigma bonds in this compound. So that is how to profile solution to a question like this. Now the next one says the IUPAC name of the following compound is. Now we said that our numbering should number to either of the side that we get to any of the functional group, any of the unsaturated functional group first. Your numbering should be from the side that we get to any of the unsaturated functional group, and this has been a bone of contention to so many of us as to which we are going to name first and which we are not going to name first. Now let me clear the air. Why numbering from the side that we get to any of the unsaturated functional group? Now we have 2 unsaturated functional group here. One is a double and the other is triple. Now in this case, which of them gets here? This is number 1 if you number, and this is number 2. From this direction, this is 1 and this is 2. You discover that we got to the unsaturated group at carbon number 1 here, while here you got to the unsaturated group at carbon number 2. So it is better we number from this side. So here will be 1, then if we number, here will be 1, here will be 2, here will be 3, here will be 4, 5 and 6. So the name of this compound would be, we have to name the substituent first. The substituent here is what? Methyl, and it's at position number 3. So we go as 3 methyl. Then the longest continuous chain has 6 carbon. 6 carbon is what? Henzane, but you say hens. Now why naming between the in and the ein? Why naming between the in and the ein? The in comes first. This is where we are having issues, okay? Let me clear the air. The in comes first before the what? Ein. So at what position is the in here? Position number 1. So this is 1 in, and then the ein is at position number what? 4. So we say 3 methyl hence 1 in and then 4 ein. And that makes option D the correct answer to this question. 3 methyl hence 1 in, 4 ein. Now the next is the same question, just maybe replication. Now we have a question like this. This question we need a maximum attention, and I will try as much as possible to explain it in the simplest way possible. Now how do we solve a question like this? The question is, hydrocarbon contains what and what? Hydrocarbon contains hydrogen and carbon, or we can say carbon and hydrogen. Now for us to be able to solve this question, we must know the mass of the individual element. Now they gave you the mass of the total compound in which the elements are mixed. For instance, carbon is found in CO2, but they didn't give you the mass of carbon, they gave you the mass of CO2. Hydrogen is found in H2O, they didn't give you the mass of hydrogen, they gave you the mass of what? H2O. So we must look for the masses of the individual element, which is carbon and hydrogen. Okay, now let's go with carbon first. I said the mass of the element, which is carbon, in this case would be carbon is equal to the atomic mass of the element in the compound. Please take note of what I'm doing here. The atomic mass of the element in the compound. What's the atomic mass of carbon in CO2? If you look at CO2 contains atomic mass of carbon as 12 and that of oxygen as 16 times 2, which is 32. So the atomic mass of carbon in CO2 is what? Is 12. Okay, that's the atomic mass. So we have 12 times The mass of the compound given is 26.53 because it's a mass of CO2 26.53 divided by the molecular mass of the compound. What is the molecular mass of CO2? Comprised of carbon 12 plus 16 times 2 for oxygen. Oxygen is 16. How many oxygen are here? There are 2 oxygen. So this gives us 12 plus 32, and 12 plus 32 will give us 44 gram per mole. So the molecular mass of the compound is 44 gram. Okay, let's not put the gram here. When you multiply this in your calculator, it's going to give us the following answer. We have 12 times 26.53 times 44. This will give us 7.23 in milligram. Now you may not necessarily want to convert to gram because everything are in the same units. Okay, now hydrogen here, let's calculate the mass of hydrogen. Now what is the mass of hydrogen in H2O? If you look at it, H2O contains 2 hydrogen, so atomic mass of hydrogen is 1 times 2 will give us what? 2. So there are the atomic mass of the element here is what? 2. Atomic mass of hydrogen is 2 times the mass of the compound. What was the mass of H2O that was given? Is 21.56 divided by the molecular mass of water. Molecular mass of water is 1 times 2 of hydrogen, 2 plus 16 of oxygen, which will give us 18 gram per mole. So molecular mass of hydrogen is 18 gram. And when you press this in your calculator, 2 times 21.56 divided by 18 gave us 2.395. So this one gave us 2.395. Now, have we gotten 2.395? What do we do? The next thing we do is to bring out the individual masses now. The first one you have is 7.23 for carbon, and hydrogen 2.395. Now divide by their atomic masses. Atomic mass of carbon is what? 12. Atomic mass of hydrogen is 1. So when you divide by the atomic mass, what are you going to have? That of carbon will give us 0.6025, and that of hydrogen will still remain 2.395 because anything divided by 1 is still at the same thing. Now the next thing you are going to do is divide by the smallest here. The smallest here is 0.6025, and this one is 0.6025. When you divide, this will give you carbon and hydrogen here to maintain space. This will be 1, and that of hydrogen will give us 3.97, which is approximately 4. So the compound is C1H4, which is CH4, and that is the correct answer to that question, CH4. Okay, now let's proceed to the next question quickly. Now the next question says an organic compound was found to contain carbon, hydrogen and oxygen only. On complete combustion, 0.15 gram of this compound gave 0.22 gram of carbon and 0.09 gram of H2O. If the relative molecular mass of the compound is 60, the molecular mass is, if the relative molecular mass of the compound is 60, the molecular mass is. Now how do we solve this? We follow the same approach to get the masses of each of the elements. Now note that the total mass of all the elements should be equal to the total mass of the sample given, which is 0.15. If you look at the one that we did earlier, if you add 7.23 plus 2.39 to give you 9.6 something, which is approximately 9.6 something, which is almost equivalent to when you add this plus this, it will be equals to what you have here. So the total masses of all the elements should be equal to what you have here. Okay, now let's take say an organic compound was found to contain. What did the organic compound contain? It contains carbon. Let's do this in this other slide. Sorry, it contains carbon and let's just follow the process through here. it contains carbon and hydrogen. So let's look for the masses of each of the elements. That of carbon is what? Atomic mass of carbon is usually in CO2 is 12, which we've established before, times the mass of the compound. Mass of compound given is 0.22. That is the mass of CO2 given, because it is in carbon that you will find CO2. So if you are looking for that of carbon, we should be looking at what? CO2 as a compound, divided by the molecular mass of CO2 is what? Is 12 plus 32, which equals to 44. So 12 times 0.2 to which divided by what? The 44, and this will give us 0.06 gram. So that is the mass of carbon. Now let's calculate the mass of hydrogen. The mass of hydrogen would be, where can we find hydrogen? It's in H2O now. H2O. Now H2O has 1 times 2 hydrogen plus what? 16 this to give us 18 gram in total. So the mass of hydrogen present in H2O is 2. So we say 2 times the mass of the compound. What is the mass of hydrogen given? 0.09. Okay, 0.09 divided by the molecular mass 18 gram. And when you press this in your calculator, it's going to give us 0.01 gram. Now finally, the last but not the least is the mass of oxygen. Now oxygen is present here, oxygen is present here, so we cannot use one particular one to decipher the mass of oxygen present, because it's present here, it's present here. So what do? We say the mass of oxygen plus that of hydrogen plus that of carbon should give us the total mass of the organic compound. Are we getting it now? The mass of oxygen present plus the mass of hydrogen present plus that of carbon, because they said the hydrocarbon was found to contain carbon, hydrogen, and what? Oxygen. The masses of this plus that of carbon should give us the total mass, which is 0.15. And this would be that of oxygen is unknown plus that of carbon is 0.06, that of hydrogen is 0.01. Everything should be equals to 0.15. When you add this and this together, what is it going to give to us? So let me put it here. To be oxygen is equals to, or oxygen plus, when you add this is not 0, please take note, this is oxygen. Okay, let me use a different pen to indicate. This is oxygen. So oxygen plus this plus this plus this will give us 0.07, okay, equal to then 0.15. So at the end of the day, that of oxygen would be equal to, there we have 0.15 minus 0.07. So that of oxygen will be 0.18 as the answer. So 0.08 rather, sorry, 0.08. So the mass of carbon now is 0.06, that of hydrogen is 0.01, and that of oxygen is 0.08. Now if you add everything together, it should give you 0.15, which is the total mass of the compound given to you. So having ascertained this, now let's take them to the other slide. So this will be carbon, hydrogen, oxygen. Carbon 0.06, hydrogen 0.01, and then finally oxygen 0.08. Now the next thing we need to do now is to follow the same approach again. Divide by their atomic mass. Atomic mass of carbon is 12, that of hydrogen is 1, and that of oxygen is 16. When you divide this by this, what are you going to have? 0.005. Divide this with this, 0.01. Divide this with this, 0.005. Now what are you going to do at the end of the day? Divide by 0.005, which is the smallest, 0.005. We are dividing by the smallest now. This is not new to you on empirical formula. So when this divide this is going to give us 1, this divide this is going to give us 2, and then this divide this is going to give us 1. So the empirical formula is C1 H2O, which is CH2O. Now, for you to get the molecular formula, what do? You said CH2O, which is the empirical formula, bracket what? N is equals to the molecular mass. The molecular mass given is what? 60. Now, we have to bring the atomic masses of each of these elements out. Carbon is 12. Hydrogen is 1. 1 times 2 is what? 2. Oxygen is what? 16. Bracket N is equals to 60. 12 plus 2 is 14 plus 16 is 30. So we have 30 N is equals to 60. Now, if I may want to complete it here on this part of the board, you have 30 N is equals to 60. To get your N, divide both sides by 30. So N will be equals to 30 divided by 60 is 2. So our N is 2. Normally, empirical formula is what? CH2O and then times what? N. Now your N is 2. So this becomes CH2O bracket 2. And when this multiply this, it gives you C2. 2 times 2 is what? H4. O times 1 is what? 2. So the compound, the correct answer is C2, H4, and what? OH. Let me write it again. We erase some things from this place. So this is C2, H4, O2, and that is the correct answer to this question, which is this option. So that will be basically all for now. I wish you success in your exam. Thank you for your time. Bye bye.